All right, everybody. This is the second question. Sorry, I'm getting to this a little bit later, but we'll finish these off. So this one's all about resistance. So the first question, A, is looking at two wires, same material, just different properties. Looks like length and width. So the first one, wire A and B, A is definitely longer than A. So it's longer here than A. And so we think about what causes the resistance. I'm going to go a little bit slower through this one. So resistivity is resistance is the resistivity times the length divided by the area. And we'll be looking at that a good bit. So this particular one, the length is bigger in this, which is going to make a higher resistance there. So the longer it is, the more resistance it has, right? Length goes up, resistance goes up. All right. If we take that same idea, resistance is the resistivity times the length divided by the area. Then, and the two wires are the same length, but one has a larger area here. Well, that one's going to go down. So A, again, is going to have the higher resistance. Again, B, the bottom, making A go up, will make resistance go down for B. So its resistance will be smaller, and so the highest will be A. So higher A in each case. A is higher because it's longer, then A is higher because it's thinner. So what makes something conductor versus insulator? Well, metals are good conductors of electricity because conductivity, electrons. How easily can the electrons move around? So a good conductor will have tightly held. Nope, definitely not that. Electrons are loosely held. Okay, two sounding good. Many more electrons than protons. Nope, they're going to have about the same. Metal atoms have no electrons. Well, that's not good. You need the electrons to flow through it. So it's the two. Loosely held electrons makes a good conductor. Insulators are bad conductors because they don't let go of their electrons. Right? Wire has a resistance of 10 ohms. You then fold it twice so that it's 1/3 the length, but that's also going to triple the area. And 3 strands in parallel. So that's tripling the area right there. Parallel is going to triple the area. So what does that do to the resistance? Well, again, resistance is the resistivity times the length divided by the area. Well, if I don't change resistance, so I'll leave that, maybe I'll make that a 1. Length is now 1/3 what it was, but the area is triple what it was. Well, then that comes out to be, I believe that comes out to be 1/9. 1/9. And so then I'll say 1/9 times 10, and that gives me 1.11 ohms. Right? So both of those changes are going to decrease the resistance, making it shorter, decrease resistance, making it fatter, or adding the area decreases resistance. So we're going to drop it way down to 11. All right. So round wire has a resistance of 12 ohms. Now this one's a little weird. It's talking about diameter here. Diameter comes into the equation for area. This is a little bit tricky. So area is pi r squared. Pi r squared. All right. Now, doubling the diameter does the same thing as doubling the radius. So that's just going to put a 2 in there. So our new equation here looks a little different. Radius equals rho L over area. So rather than area, though, it's going to be this rho L over pi r squared. All right. And more on that in just a second. So let's go back through it. Round wire has 12 ohms. So we're going to multiply 12 times something. The wire is now replaced with a wire made of material twice the resistivity. So we're going to add a 2 in for that one. So we double the resistivity, twice the length, and twice the diameter. And here's the tricky part. This is pi. Pi doesn't change. R, though, is now twice what it was, and that's squared. All right. Let's move that 12. So simplifying that leaves me 4 over 4, which is just 1 times 12. So it is still 12 ohms. Again, very tricky one. Hopefully this was helpful.